Howdy folks. In this video I wanted to go over variables in JavaScript a little bit because I think there's been a little bit of confusion over that and we didn't have a ton of time to go over a lot of the intricacies of them. So, variables are generally used for storing data for later use, be that strings, user input, functions that you want to call, arrays of data, etc. Variables will always have a name. This is how JavaScript knows that you're referring to the same variable. As long as the name is within the limitations of the variable, then JavaScript doesn't actually really care what you name your variables as long as you have use the same name everywhere. It is literally doing a find, just a control F, and if it sees that variable name again, it knows what you're talking about. It's not going to glean any context from what the variable is called. If you name it number of people and you give it someone's name, JavaScript is not going to bother to check that for you. Variables can hold numerous types of data, basic primitive types, more complex types like objects or arrays. They can hold functions. They can hold elements. We went over that last class, stuff like that. So defining a variable, it's a pretty simple pattern. We start off with var. We also use let or const, but we haven't really covered those yet. So for now, we start with var. And that's a keyword that tells JavaScript that we're defining a new variable. As soon as JavaScript sees that keyword, it's going to expect this pattern because it knows that this pattern is pretty much the only thing that you can use for a var, with one exception that we'll get into a little later. The next thing it wants after a space is the name of the variable. This can be letters, numbers, and an underscore, or multiple underscores. It cannot start with a number. That's just a limitation in the language. Most high-level languages are like that. So you could have name1 or name2 or name underscore 2, but you can't have one name starting with like the number 1. Then there's an equal sign. And the equal sign and the part that comes after it is technically optional. Once you've said var and the variable name, you've defined a variable. The equals operator tells JavaScript we're now going to set the value of the variable. And that can actually happen if we're setting a variable that's already been defined as well. In that case, we just cut out the var and we just have the variable name equals. The value can really be any JavaScript statement, and that's any JavaScript code. We'll go over a bunch of examples of this later, but the right-hand side of this expression, we call it left hand and right hand because the operator in this case is the equal sign. The left hand side is the variable name and the right hand side is the value. The right hand side can be very flexible, any code you really want. So let's go over how JavaScript handles this stuff. This is going to be a very high level thing, but I think it's important to understand how it works. We've got some code here. That's the code we're going to run. Then there's the symbol table. Well, and we'll go over that in a little bit more detail later, but what JavaScript uses the symbol table for essentially is it uses the symbol table for storing what variables map to what location in memory. And then we've got a representation of the memory. That's not actually what memory looks like, but it's a good representation. It's pretty common if you see memory represented to be like this. You notice it starts from 0 because all memory in computers is 0 indexed. So we execute our first line of code. The first thing JavaScript does after seeing var I equals 5 is it says, okay, I better create a variable called I. So it inserts I into the symbol table. This is because JavaScript knows the next time it sees I somewhere, it has to look up that memory that I points to. So it puts that into the symbol table and says I points to memory location 0. Why does it pick 0? Well, 0 is the first block of memory that was unallocated, was not used. And that was because we didn't use any of our memory. And then it stores the variable 5 at location 0 in memory. So you can see when JavaScript, as far as JavaScript is concerned, 5 is at memory location 0. And we could, if this was a different language, actually tell JavaScript to look at memory location 0 instead of using I. But using I is much more convenient because JavaScript has a bunch of complicated memory management stuff, and so it also knows how it's handling the memory, so we don't have to deal with it. Lower level languages like C++ allow you much more direct access to memory, and assembly, in fact, allows you to load memory from a number, which actually causes a lot of errors in some cases if you do it wrong. So JavaScript uses the symbol table and variables to make that process a lot easier for us. Let's go on to the second one. Okay, so now we execute var stir equals foo. JavaScript again makes an entry into the symbol table and adds in stir as the symbol, and then it's at memory location 1 because memory location 1 was the next open spot in memory. And what it does as well here is it will go into memory and it will actually add 4 entries, and that's because each memory location on most machines is going to be either a 32-bit or a 64-bit value. Characters, and this is stuff that you probably don't need to care about too much, so don't worry if this is confusing to you. But basically every single individual character of the string needs to be in its own memory location because that's just how memory works. At the end, we have that /0. Now what that is that's called the null termination character. And this is a little more esoteric, but the reason for that is, you notice JavaScript at no point stores how long that string actually is. So if you went to console log that string, as you can see we're doing later on, how does it know when the string is done? If it looks at just memory, it doesn't know that there's only 3 characters in that string. So what it does is it goes F0 or O, and then it hits that /0, and that null termination tells it the string is done. Now again, JavaScript handles all of this for you, but it's just kind of an interesting little thing to know about. So the next one, we have J. And j is equal to I. Now here's an important thing that we will cover later on. Primitives are copy by value. So we make another entry into the symbol table here, and that gets memory location 5 because that's the next memory location that's available. Then we copy the value from memory location 0 into memory location 5. So now both 0 and 5 have 5, incidentally. I probably could have picked a better number for that, I'm just realizing. But yeah, so j, even it's pointed at a different memory location. It has the same value as I, but what that var j equals I does is it allocates more memory and copies that value over. Then when we hit console log I, the browser sees that it needs to access I. It goes into the symbol table and says, I need I. Where is I? It looks up, oh, I is at memory location 0. It then looks at memory location 0 and pulls out that 5. And says, okay, I have 5. It returns that back to the function that needs it, and then it handles that. When we get to the string, the browser says, okay, let me look up string, or str, in the symbol table. It picks up memory location 1, and then starts printing until it hits 4, hits the null termination, it's done. And again, JavaScript handles all that for you. You will never need to worry about that with JavaScript, but it's just kind of interesting to see. Possible values. Variables can be set to point to any piece of data. They can be set to point to scalars. Scalars are a single value or unit of data, usually a primitive type. So we can see a couple examples of that here. These are 5 variables being set to scalar values. And as soon as you set those, they get sent into memory like we just went over. You don't necessarily need to remember this is called scalar. I actually just looked it up because you're not really probably going to refer to them that way, but it's the type, it's like the class of data is a scalar. And we have a number, a string, a boolean, and another number. They can be set to another variable. And in this case, because it's a primitive type, j will get set to a memory location and JavaScript will copy the value over. And so this is what happens, depends on that variable's type. If you're doing an array, an object, or a more complicated value, it's a little more complicated what happens, but we'll get into that a little later. So in this case, because it is a primitive, I is a primitive value, that 5 gets copied over into whatever location j points to. So now I and j are pointing at different memory locations that just happen to have the same value. And if you change j, you won't change I. You can set it to a complex structure like an array. So we see we have a primitive here at the top, I equals 5. We have arrays, and arrays, I want to go into this a little bit more. They are going to be, and you see all of these so far have had that same structure. Var, variable name, equals, and then some complex statement. In the case of the first statement here, that complex statement is just 5, which is fine. In the second one, it's actually an array initialization statement. So we have 5, 6, 7, which are all numbers, str, which is a string, and true, which is a Boolean. Arrays can contain different types of data. So this is a little different from other languages, such as Java or C++, where arrays can only contain one type of data. So if you declare an array of numbers, it can only have numbers. JavaScript arrays can contain anything, which is both good and bad. It gives us a lot of flexibility, but it also means that we have to do more checking to make sure the data we're dealing with is what we expect. Arrays can also contain other arrays and other objects. Everything inside the array brackets, like that comma, you can use any statement there as well, just like assigning to a variable. Objects, same thing. We have that key value pair, and that's a similar format or similar idea to variable assignment, where we have key name, colon, and then some complex statement, which could be any of these possible values. So it is kind of almost recursive, as we say, and you'll hear that word a lot in JavaScript. So the key is going to be a primitive. Foo is going to actually point to a variable, the variable I, and this is actually the same thing as we talked about before. Because I is a primitive, foo points to a memory location that is not the same as the memory location I points to. It just copies that value over into its new memory location. Bar becomes the fourth element of the array, which is str, and it's a similar thing. Because str is a primitive, bar points to a new memory location that just contains, or a set of memory locations that contains str, whereas the array r, its fourth element, is unchanged. It's its own memory location. So I just want to clarify on that, that if you're setting something equal to an object key or an array value or another variable that is a primitive, it is copies that variable to a new memory location. A variable can also be the result of a function. It can be so I equals math.floor. Again, this follows the same rules. So if the function returns an array or an object, it is copied by reference, which we'll cover a little later. If the function returns a primitive, that primitive value gets copied from where it was. And when you return a value from a function, JavaScript makes a temporary entry in the memory location that it knows that it's where it's storing that variable or that value, and then it copies that value to wherever you get to. And that might be a little confusing, but and it's something you don't really have to deal with too much. Just keep in mind that it's the same idea as setting to a variable. If it's a primitive, it copies the value. So variables can also be a function. And the way JavaScript handles this is really complicated, and that's to do with some really clever stuff in memory. But in this case, I becomes a function that is callable. So we have j equals I, and then in parentheses, because we're calling it as a function, j at the end of this will be 5, because the value of that function returns 5. And again, j will be that primitive value. A variable can also be set to null. Null is a special value that we use to indicate nothing. There's nothing there. This is empty. You can also set it to just nothing. If you just say var and then the variable name and then a semicolon, JavaScript will still define memory for it. However, that memory will be empty. And so we call that undefined, which is similar in class to null, but it's a little different because null is you've explicitly said nothing's here, whereas undefined is JavaScript's just saying, I don't know. You didn't define anything for this. So in practice, they are generally considered the same, but they do have to be handled sometimes a little differently. So it's just good to keep that in the back of your mind. So pass by reference. When a variable is set to an existing array or object, JavaScript does not copy that data. It does not make a new memory location. So in this case, you see we have an object we're defining. So JavaScript creates a memory location for that object. Let's say it's memory location 5. And then it sets object2 equal to object. In this case, that symbol table that you noticed that we had before, both object and object2 will point to 5. They will point to the same memory location because this is not a primitive. And in fact, what that means is if we change object2.foo to 6, it actually changes the original object as well. And so if we console log object foo at this point, even though they are different variables, the fact that they point at the same data means that object foo now becomes 6 as well. You notice this does not change I, and that's an important distinction. And this is kind of confusing. And I understand. Maybe I should have actually made a little table for that, but I didn't think to build that. I is a primitive. So when we create our object on this line here and we set foo equal to I, this value gets copied. Foo does not point to the same memory location as I. However, object2 points to the same location as object, and that's because they are object types. They're complex data types, and JavaScript doesn't copy them. Which means that when we change object2.foo, object2.foo is the same thing as object.foo, but because we copied the value for I, it is not the same memory as I. Which means if I was to console log I at this point, it would still be 5. This is important in a lot of ways because if we want data, for example, we want to pass some data into a function and we want that function to change that data, we have to pass an object in most cases because the object remains pointed at the same memory. If you pass like a string into console log, JavaScript will actually make a copy of that string. And then console log works on that copy. And I know that's probably a little complicated for you to bear in mind because it is a little complicated. Just keep in mind that primitives copy, complicated ones do not. So if you change a key, whoops, wow, that's not what I wanted to do. If you change a key or a index on an array on a variable that's been set equal to another variable that points to that complex data type, it's going to change the original variable value as well. Similar to array, we have an array of 5 integers. We set array2 to point to array. They point to the same location in memory, which means that if I set the first element of that array to 4, and then I print the original array, it's going to have also changed. It's not going to be the original value anymore. And that's pretty much it for now. I recognize this is really complicated, and in a lot of cases, you're not going to need to worry too much about these distinctions, but it can be really important to consider this stuff especially if your code isn't behaving exactly as you should. So I hope this helped. If you have any other questions, maybe even questions that this caused you to think about, then please feel free to reach out either in Slack channels or in comments on the video. Totally up to you, and I will be happy to answer them. I'll see you in class.